There's an invisible crisis happening all around us, and even inside of us. But what if the solution wasn't just a better filter? What if it was something you couldn't even see? What if we could actually use sound to clean our world?
Yeah, that's not a hypothetical. That's a stark scientific reality. These tiny, tiny plastic particles have worked their way into every corner of our planet, and now they've worked their way into us. That really is the billion-dollar question, isn't it? And the answer, well, it might just come from a breakthrough that sounds like it's been pulled straight from science fiction. Okay, so to really get why this new solution is such a big deal, we first have to wrap our heads around the massive scale of this invisible problem we're all facing. So when we say microplastics, what are we really talking about? Well, these are fragments so incredibly small, they're measured in micrometers. To put that in perspective, that's 1,000th of a millimeter. They come from everywhere. Plastic bottles breaking down, synthetic fibers from our clothes, bits of car tires, even old cosmetics. And here's what's truly mind-boggling. This isn't just an environmental problem that's happening out there somewhere. These particles have been found absolutely everywhere, from the bottom of the deepest oceans to the ice on the highest mountains. And now, as we know, they're in the food we eat, the water we drink, and they've made their way deep inside our bodies.
So you might be thinking, why can't we just filter them out? Well, we do try, but our current methods are kind of like trying to catch dust with a fishing net. The filters get clogged all the time, they use a massive amount of energy to run, and a lot of the tiniest, most dangerous particles just slip right on through. We desperately need a whole new approach.
And this is where that new approach comes in. It's something truly futuristic that engineers have been working on. See, instead of trying to block the plastic, what if we could just push it aside? It's a technology called acoustic tweezers. Now, the name sounds super complex, I know, but the basic idea is actually beautiful in its simplicity. It uses high-frequency sound waves to create an invisible force field in the water, a force that can physically move microscopic particles without ever actually touching them. It's kind of amazing. But how in the world do you turn sound into a force that can sort microscopic trash? Well, it all comes down to some really, really clever physics. Okay, so try to picture this. Water, full of microplastics, is flowing through a small channel. On the sides of this channel, there are these little devices called transducers, and they create what's called a standing sound wave across the water. Now, this wave is like a series of invisible guardrails. As the tiny plastic particles float by, the sound wave just gently pushes them into these neat lines, almost like sorting cars into highway lanes. This separates them from the main flow, so the clean water goes out one exit and a concentrated stream of microplastics goes out another. And the reason this magic trick works is because the sound wave affects plastic and water differently. They have different physical properties, a different density, a different compressibility. The system is smart enough to exploit this tiny physical difference, this acoustic contrast, to selectively push the plastic while letting the water just flow on by. And get this isn't just a cool theory. In the lab, this method is already showing over 90% removal efficiency for all sorts of different microplastics. That number is a complete game changer, especially for a technology that doesn't even use a physical filter. But of course, no new technology is a silver bullet. As incredible as the potential is here, there are some pretty big real-world hurdles to get over before this is in every city's water plant.
So let's break it down. The advantages are just incredible. A system that never clogs, that's the holy grail of filtration right there. It's chemical-free, it's super efficient, and it concentrates all the plastic into one easy-to-handle stream. But on the flip side, the challenges are very real. How do you scale this up from a little device on a lab bench to something that can process millions of gallons of water for a city? The initial cost, the complexity, and the energy needs at that scale, that's the stuff they're working hard to figure out right now.
So while the engineers are tackling the massive job of scaling this up for our drinking water, the core principle behind it, using sound to move tiny things, is already opening doors in some other really fascinating areas. This is so much bigger than just plastic. You could use the exact same technology in medicine to sort different kinds of cells without damaging them, or in industry to separate out valuable materials during manufacturing. You can even imagine a future where a tiny version of this is built right into your kitchen tap, giving you a final, perfect layer of purification right at home. So yeah, the road from a brilliant lab concept to a global solution is definitely a long one.
It's going to take some amazing engineering to make it bigger and cheaper, and of course, it'll need tons of testing to pass all the regulatory standards and earn our trust.
But it all starts with a huge shift in how we think. For 100 years, we've tried to solve problems like this by blocking the contaminants. And now we found a way to simply push them aside. It's an elegant, powerful idea that leaves us with one really exciting question to think about.